Welcome to Category Theory for Data Scientists. This is a series of advanced mathematical videos for data scientists. We will cover category theory, group representation, graph, manifold, and Lie theory. In this video, we will cover category theory. So what is a category C? It is a collection of objects, a set of morphisms, a composition that we can combine morphisms, and an identity morphism for every object. And it has to satisfy these two axioms, associativity and unitality. Suppose that we have these two objects, A and B. The objects are really general in category theory. That could be anything. The morphism connects these objects. It works like maps and arrows. We can have more objects and more morphisms. And there is a composition of morphisms between these objects. And also every object has a map to itself, an identity map. Here we can see the associativity and how it works. We can combine arrows in different orders, but it doesn't matter how we are combining them, if the source and the destination are the same. Let's see an example. The familiar set and functions are object and morphism. We can have a morphism that exists if a number divides another number. Or we can consider a group. The group itself is an object, morphism are the elements. Now we know category theory definition. We can move to other concepts like functors, which maps categories. So a functor is a map between different categories. That for every object there is an object in the destination category, and for every morphism there is a morphism there. We have these two laws also. The identity, which sends the identity to identity, and composition. Consider the category C with three objects and these two morphisms. As you know, we have an associativity. Now, by a functor, we can transfer this object and morphism to another category. You see that it preserves the composition in the destination category. And we said that every object has an identity map. It also preserves the identity. Given two functors, we have a natural transformation. So a natural transformation is a morphism that satisfies a naturality condition. Let's see this in action. Suppose we have a source category with two objects and a morphism in it. So x and y are our object and f is the morphism. Functor f and functor g is our two functors. A natural transformation alpha x and alpha y connects these two functors. And we call this square in the destination category a naturality square. and this is basically the naturality condition. Next, we have unit lemma. The unit lemma is the most important lemma maybe in category theory. It says that objects are determined by their relationships. We don't have to know the object. If we know every map that there is to an object, we can guess what that object is exactly.